Hello, my name is Joshua Gaitan, and my team consists of Hugo Diaz, Sebastián Franco, Naomi Delgado, Francisco Ramirez, and Osiel Avila. We complete practice 3.2. The proposal of this practice is to apply the several communication protocol programming the Arduino board to beach like a low-cost DAK using digital communication. In other words, it allows you to write digital output and read digital input.
We will start working with our LabVIEW software, which allows us to create our program to control it directly with external components. In this case, the external components we have are the Arduino and the buttons, as well as the 1 kilo ohm resistor. And the component extra is the cable or jumper.
To the declarations, and we declare the digital outputs, digital inputs, and the variables, and then we start with the setup, and we wrote the voice setup, and we start to the declaration of digital outputs, and then we declare the digital input that are also four, and then we uh, we wrote the serial port configuration that is that begin 1600, and later we output initialization to set to 0, and then we ending the setup and start with the main loop, writing void loop, and we start with a condition if, and we start to attention to command A, writing of the digital outputs. Then we close that, and we start with the attention to command B, the digital entry reading, and we close that, and we finish the main if, and we finish the main loop.
To obtain communication in LabVIEW, specific blocks are used, such as the serial port, which tell us which port is connected to the Arduino and from where it will receive or send information. Then we have the write block, which is the one that sends the instruction to the Arduino and they are executed physically, and the write block, which is the one that receives the instructions from the Arduino and they are executed on the front panel. Below we have the local variables of the physical LEDs that when the LabVIEW buttons on the front panel are pressed, the state will be sent through a conversion from Boolean to string, and conversely, the state of physical button is read by Arduino and sent to LabVIEW to turn on the LEDs on the front panel.
For the part where we're using physical buttons, first we have to implement the serial communication with Arduino. Then, as we have physical buttons, we have to read in LabVIEW the state that the button is sending to LabVIEW. So we have to read first the value, and as we have four LEDs that will be turning on, we have to move the number as the position that we need. So we have to put 0, 1, 2, and 3 to move the position and take the value that we want.
One LED can be turned on at a time by pressing one button at a time, or all the LEDs can be turned on by pressing all the buttons and turned off in the same way. In addition, if the buttons found of the front panel of LabVIEW are pressed, the physical LEDs that are connected will light up.